Well, my name is Giuseppe. I am a PhD student at Loughborough University. And today I'm going to present the results of my first 6 months of PhD, basically about AI for transport infrastructure resilience. So, in the last 12 months, across Europe and the globe, we have seen too many disruptions created by climate weather events, extreme weather events, like causing the different consequences like economic losses, bridges collapsing, or even like injuries for the people, or even deaths, like in Portugal the last year during the wildfires where people were trapped in the cars. So because of this, it's important to speak about transport resilience and transport infrastructure resilience, because there is an increasing pressure on the existing systems coming from climate change effects. But on the other side, the solution that we are proposing, for example, specifically about AI applications, can also create some pressure on the infrastructure systems, because it is creating, for example, or it can create more complexities and more interconnecteds of transport with another different systems like telecommunications or another ones. So the question that we are making here is, how can we assemble the AI developments to drive the digitalization and automation in the right direction regarding the climate resilience? So to do this, the first step obviously was carrying out like a literature review and trying to understand what is the current state of AI developments in transport. So we gathered some studies on this, and we tried to simultaneously cluster them or classify them, like what is the purpose of AI or these developments in the context of transport, and how can these be linked to transport resilience. So the idea of this is to evaluate the potential of AI regarding this challenge of resilience, and ultimately to create a pathway to optimize the implementation or incorporation of AI tools or applications to enhance transport infrastructure resilience to extreme weather events. So for this, we proposed this framework, which is coming from structural engineering. Actually, we adapted the 4Rs resilience framework that says resilience can be defined by these 4 properties: robustness, redundancy, resourcefulness, and rapidity. And this can be seen through technical, social, economic, and organizational perspectives. So what we're saying is, okay, for the matter of transport, then robustness would be like that capacity, for example, of a transport link connecting two cities to be basically more strong or like more resistant to withstand like a disruption coming from a weather event. Redundancy would be the extension to which, for example, the lost capacity on one link can be coped with the capacity on other links in the transport network. The resourcefulness would be the capability to efficiently mobilize the resources from one place to other to attend, for example, an emergency and to avoid a disruption or reduce the possible impacts. And the rapidity is when we have already suffered the disruption in the transport network, how quickly can we recover the lost capacity. So we collected around 10,000 papers from 2020 to 2025 speaking about AI and transport infrastructure. The first task that we did was looking for, okay, how many of these are actually stating the word resilience. So just around 200 papers were stating resilience, resiliency, resilience, something like that. But it didn't mean that the rest of the studies do not have the potential to address resilience. So we carried out like a co-occurrence analysis with keywords that allowed us to identify other studies that can potentially address resilience unintentionally. Like the authors are trying to say, okay, this AI application is to withstand a disruption or to recover from a shock or to resist a weather event in the context of transport. So we say, okay, maybe it is potentially useful for this challenge. And following that idea of doing the co-occurrence analysis of keywords, we try to say like, okay, we identify how many of them are maybe speaking about resilience, but how are they addressing resilience regarding this framework that we created, like the properties and the dimensions. And what we found, not surprisingly, is that most of the studies are when we classify them in these two dimensions, most of the studies are trying to increase the robustness of physical assets from a technical perspective, while there is another flat area for the rest of the dimensions and properties, especially, for example, for the social dimension, where we see that there is not too much said about how can AI be used for that dimension, for social resilience, let's say. So, okay, this is like giving us an insight of how AI can be used for this purpose in the context of transport networks, but it is not answering the whole question of how are these applications being used in the transport system. So we took a step back and tried to find the purpose of the digital tools, like the digital technology. Like, okay, for example, there are AI applications for autonomous vehicles, for traffic control, or well, in general, traffic management, for infrastructure condition monitoring, for road safety, and other purposes. So this was useful to find if, for example, like evaluating qualitatively the different applications, for example, AI applications for structural health monitoring, we found that regarding the framework that we created, they could, for example, increase the robustness across the technical dimension, but they can also, for example, help the transport managers or infrastructure managers to mobilize easier the resources, to be more efficient in the maintenance works, and therefore creating more robustness, for example, in the organizational aspect or the economic aspect, and obviously increasing the resourcefulness of the organizations. Similarly, we can do this for different applications, but the interesting thing that we found here is that, okay, there are different methodologies across AI to do the same task regarding transport, like, for example, having tools to create dynamically changing traffic signs. And that purpose is the one that can help us, like, enhancing the resilience of transport systems. So they can, yeah, again, like, address the robustness of in the technical dimension, but they can also, for example, increase the rapidity for the transport network to recover, like, the lost capacity. They can help organizations again mobilizing resources faster and more easily. But at the same time, that question mark there is, again, like, they can create complexities, and organizations can become weaker if they don't if they are not aware of the related or inherent complexities to implement new technologies in the transport infrastructure. So basically, what we found until here is that there is a growing connection between AI developments and resilient transport infrastructure challenges, even though the authors of the studies in AI are not aware of that. I mean, there are a lot of tools being created right now that can be used for that, and maybe authors are not still conscious about it, but our idea is, like, to assemble these applications for that purpose. As I said before, like, most of that potential of current developments of AI is lying in the technical dimension to increase the robustness of physical assets, but there are also other growing potentials, like to improve the rapidity from technical perspective, or also to improve the robustness from economic perspective. Still, there is further research that we think should be carried out to explore the resilience across, for example, the social dimension, as I said before, not because the current developments are not useful for that purpose, but because there is no bridge connecting these two things yet. So, yeah, basically, that's it. Obrigado. And if you have any questions, I'm more than happy to answer.